Following a feature engineering, next will be our train test split. Since we are dealing with time series data, so we are going to see another thing called time series split. So this is under time series split from SQL and model selection. So this is a time series cross validator. Where it is, other cross validation methods are inappropriate because we need to split the time ordered data, as they would lead to training on future data and evaluating on past data because of the shuffling. So to ensure comparable metrics across full samples must be equally spaced. Okay. Once this condition is met, each test set covers the same time duration while the train set size accumulates data from the previous split, so that there will be no data leakage. Okay, so this cross validation object is a variation of our usual k fold. In the kth split, it returns the first k folds as the train set and the k plus 1th fold as the train set. Okay, so that the past and future will not get mixed up. Okay. See, unlike standard cross-validation methods, successive training sets are supersets of those that come before them. Let's see one by one. This is the implementation. So TSCV, time series split, we have given gap 0 and end splits 5. Here, for the first fold, train will be the 0, index 0, test will be the index 1. For fold 1, the training set will be 0 and 1, test will be 2. See, k plus 1th fold and the supersets. Okay, so in this way we will be training it. This will be very much important for time order data, because the flow, the continuity is important. Because weather data is chronological, as we have already seen, we cannot use a random split, right? So random splitting could allow future observations to enter the training set while the older observations appear in the test set. So that will be inappropriate, as mentioned in time series split. So this would not represent a real forecasting scenario and create a temporal leakage. Okay, so instead we are going to use chronological train test split. That is, the earliest 80% of observations become the training data. So we have taken 2015 to 2026 data. So here 80% of data will be our training set and the balance 20% will be the testing, but this will be in a order. Okay, so 80% of observations become the training data, while the this 20% will be final test data. Okay, so this 80% will be past observations to say, and this will be recent observations, right? That is our future. So the training set is used to develop the model and also to select the model. The test set represents the unseen future data, which is a common explanation we will be seeing for our test set. And one main thing is we should use the test set only for the final evaluation. Also, inside the training portion, we will use the time series split, which we saw, for cross validation. So unlike ordinary cross validation, this will preserve our time order, and it uses the training window expansion, that is this. The window will be expanded 0 to 0, 1, 0, 1, 2, 0, 1, 2, 3. Also, if you mention any gap around here, see, if I have a gap as 2, my 4 indexes will be 0, 1, 2, 3. It will leave 4 and 5, and the test set will be 6 and 7. Also, if it is 0, 1, 2, 3, 4, 5, it will leave the other 2 as gap, and test will be 8 and 9 index. So with this, the training windows also we can expand. Okay, so in every fold, like a cross validation, the model learns only from the earlier observations. Okay, and it will be evaluated on the later observations, that is a future observations. So this simulates how the model would behave when making the real forecast over different historic periods. Okay, so the important distinction here is the chronological train test split. Okay, so this will create one untouched final test period, while time series split is used only inside the training data. So it will never even know what the tested data will be, right? So we'll be using only the training data, and the splits will be made inside the training data. Okay, this will be used for model selection and hyperparameter tuning too. Okay. let's start with train test split from sklearn dot model selection import train test split. Okay, our data is in feature df, right? So our target variable is temp max next day. Okay, target variable with the shift of -1. Okay, so we have to define our x and y variable. Our independent features are from the feature df. I'll have to drop only the last column, that is enough, so that other columns will be selected. I'll be using the drop function, so columns will be only one, temp max next day. Okay, fine. So I'll close the bracket. Next y will be only the temp max next day. Okay, let's see. Print x dot shape and print y dot shape. 4166, 18 columns. Before that we had 19 and now it will be 18 because we have dropped only one column. And the y, it will be a series, only one column. That is our target variable. Now usually what we will do for a train test split, x train, x test, then y train, y test. So train test split. So here first x train and x test will be from x and y train and y test will be from y. Here test size is 20%, so 0.2. Finally shuffle will be false. Okay, we are maintaining an order in here so that there will be no shuffling and no random splitting here. Okay, finally we can see the train and test shape. So train will be 3332 rows, test will be 834, which is 20% of our total row. So what we have mentioned previously was inside the training set we will be introducing the time series split. Okay, so let's see. So the same I will import from sklearn.model selection. So you can add a comma, no problem with that. I need to have a separate thing, so that is why. Okay, for clear understanding. So now this will be a cross validation that is well aware of the time. So I'm going to call it as time aware CV only for the training set, right? So TCSV, I'm using the same variable name as from the sklearn documentation. So time series split will have n splits 5. So I'm just going to give the splits 5, no gaps, nothing. We'll keep it simple as possible. So for every fold in I'll get the train and val, right? See, train index and test index. Okay, that will be from our splits from the TCSV. Okay, I'll get two indexes. I have tuple it and train ID and val ID in where in my TCSV dot split of, we are going to split the x train only and not the other. Okay, so we need to have an enumerate, and I'll give the start value as 1 to start from 1 instead of 0. Okay, now I will have xfold train value, xfold validation, then yfold train, yfold val. Okay, so let's see one by one. This is x train, ILOC of train ID. Okay, next the val ID, this one. Okay, from x train I will locate the index of this val ID. Okay, now I will also take the y train dot and locate the train ID. Okay, and y train, and I will locate the val ID, so that we are getting both x fold train and y fold train. So for every train data we have splitted it x train and y train. So our desired maximum temperature is in y train. So we are passing the same train ID and val ID to the y train to get the corresponding maximum temperature of that x fold and train and val. Okay, so same indices will be sent to both. So this is the data we will be using to fit the data also. So finally we want to see how this is happening, right? What to say, f, I'll get x train now, that is x fold train dot shape, then which will be, I'll oh god, sorry. So our total training data is 3332. Now with 5-fold, oh, I've changed the order. Okay. For 5 folds, our training data set will be 2777 and validation will be 555 from this training set. Okay. So since this session is completely dedicated to our train test split and with the time series split, so we can visualize this train test split to understand how our time series split and the chronological train test split works. Okay, first will be visualizing our chronological train test split, right? So for this I'll be using our Matplotlib. I'll import the library, import matplotlib.pyplot as plt. So okay, first plt dot figure, I have to give the fig size, that is a figure size. I'll go with 8,4. Okay, 12 comma 6 or 5 will be enough for the size. So by taking the y train dot index, we'll be taking the index of y train. We are taking the row index. Okay, so we already have the train test split, so we can clearly see the data split in number, so that by taking y train index, we will get the row index. Okay, let's see. So first plt plot or y train dot index comma y train data, and label it as train comma color is blue and red, so it will distinguish the separations correctly, clearly. Next, test. This will give us our row index. I'll take the test. Label will be test. Color will be red. Okay, so then we need a so how this is like, how we are going to visualize this is, we will in the y train, because this is in chronological order, we can see the how the train and split has been done in that chronological order, that is in an order. So instead of, I'm bad at explaining, I guess, so when you see the visualization it will be clear. So I will have a separate line to notify where the test starts. So I'll have a split index here, that will be length of the y train. So this will show us where the y train ends and where the y test starts. Okay, so next axv line, and that will be my split index. Then color will be to clearly to see, I'll have black. Line style also, I have to give line style, which is hyphen hyphen. Shall we name it? Okay, label train test split in chronological order. Okay. Anything else? Okay. So finally, labeling plt.x label, plt.y label. I need to see the legend also. Okay, before that we will name the x label. This is time index. We are seeing it in days. Then this is y label. This will be our maximum temperature. So, okay, let's see the visualization here. Yeah, see, we have got. Okay, this will be 3777. So here, sorry, 3332. Right, this is 4166 is a total data. After splitting, we have got 3332 and 834. We have got a split, so we have given red color to y test and blue color to our y train. So this is a clear split here. So this is 80% of data, and this is the remaining 20% of data. So also, if we are considering, this is a number of days, right? What if we can see this in year? The same thing, okay? Instead of days, we are going to see it in year, because that is our primary starting point, like the 10 years past data. So we will see how it is split in years. The same thing, okay? So let's see. Plt dot figure, I'll give the figure size, that is 12,5, same as before. We will plot our now we have featured the data, right? So we will use the feature df date thing, and till I will get the data till y train. Okay, now y train, and I will label it as rain, and the color will be blue. Next, plt dot plot feature df of date. This is len of y train. Okay, and oops, sorry. Okay, and here y test, label test, and then plt.ax v line, the black line like this, that will be based on our feature df of date. I will locate the y train length, the end of y train, same as before, the length of y train. Okay, and the color black, line style as this, and label as train test split. Okay, then finally x label, y label, legend. So I will name the x label time index. This will be in date. Previously it was days, and now it is in date. Next, y label, it will be max temp. Finally I will show the visualization. See, well, so the same split till 2024. Okay, from starting from 2015 to 2024, we have got the train data, and the test data will be the recent observations, that is mid of 2024 till 2026 current date. Okay, so this will be the visualization of chronological train test split. So also there is one important visualization that is actually new for me to visualize. This is the first time I'm going to experience the same. Okay, we have the time series split, right? So we have 5 splits, and we have to enumerate through the splits, and let's see how it will be, like in this, like it will look like this visualization. For that, I'll write new the split count as 5. Okay, and we need the y train for this. Okay, okay, y train, I'll drop the index, sorry, I'll reset the index and drop it. Okay, so reset index, and I will drop it. Now it is ready to plot, okay, the train data. So next will be my TCSV, that is time series split, that is n splits, which will be our split count. This is the same as what we have done here. Okay, so nothing much. So okay, now for visualization purpose, I'll use TCSVB. Okay, now because we have 5 5 splits, we'll have a subplot here. I'll have the figure and axis defined here, which will be plt dot subplots I'll give the split count. Okay, for every plot, fig size will be 8 comma 5. No, we'll have the same 12 comma, we need to have 12 comma 5 is enough. Okay, 12 comma 5 is enough. Then I'll share the axis so that they will have the, what to say, they will have the same. Okay, this will be next. For every fold, wait, I'll come. Train ID, then val ID, enumerating it through tcsv underscore v dot split of xtrain. For this time series split, we are using the xtrain, right? And from that we will get two indices. One is the train ID and one is the val ID. And for every fold, we are going to work on this set. Okay. First is axis of for every fold. Next, the plot. Ax dot plot of first is my train ID. Okay. Then y train plot is our data, nothing much. So that is we are using the y train for this particular visualization. So I have used y train plot. I will locate the train ID here. So color will be the same, tab blue. Next will be the label train. It is same as before. See, so we have given y train index, y train and label, right? So the same I have done here. Okay, train ID, y train plot, and for every y train plot I have taken the train ID, locating the train ID in the y train plot. Okay, now ax dot plot val ID, it will be y train plot, locating the val ID. Okay, color tab red, label will be test. No, here okay, so since we are using the train and we already have a test, we will have this as validation set. Okay, and we are using red for test, so I can make it to orange. Okay, now the line, the one line that separates, so AXE line where I have the val ID of 0, color will be black, the line style, then the label. This is where our validation starts, right? So let's keep it simple. Validation starts from this point, this line. Next it will be axv.set title, that is time series split for the fold. Let's say fold will start from 0. Okay, start from 0. Okay, here fold will be fold plus 1, so that we don't disturb the order of execution. Now setting the y label, that will be our maximum temperature. This is the same. Then the legend for every axis will be, I will locate it in upper, this is center, so it will look better here. So upper left. Right. So next, okay, finally the common thing, -1 set x label, which is time index. This will be in days because we are using the Y train and X train, so it will be in days. Next plt dot since it is subplots, we will have to give plt dot type layout, then plt dot show. Let's see, we have mentioned for every fold one plot with train and val. I will locate the train ID in my Y train plot and get the value, and we'll give it a, we will have like the time index will be in days, so that the graph will be blue for the train set. Again for the validation, plot the validation ID to the Y train so that we will get the validation set. I am quoting it as orange. Okay, the line will start with the validation, where the validation starts, training ends and where the validation starts. Color will be black, line style. Okay, this is where the validation starts. I'll say the title also so that we can see 1 2 3 4 5 folds, and a Y label will be maximum temperature and spelling mistake. The legend will be on the upper side, upper left side. So axis of -1 dot set x label, that will be index in days. Okay, title layout show. So what can we expect in this visualization? Any idea? Because for me, I did a practice before typing this. So what is going to happen is a visual understanding what we have seen as a definition. Fixed size is not defined. Oh, equal to. Set title is not defined. Wait, we'll first. Oh, sorry. This has. Okay, we are getting it. Oh, now I need to give. Okay, let's see. Okay. So as fold grows, our training step also. Okay, like we can see, right, for every fold our training set grew, right? For the first, this much of training set was taken, and for the second fold the next set of training along with that, and for the next 3 will be taken, so the fourth will be the test validation set. So likewise, the future observation is not seen in any of the training set and only inside the training set, and we didn't use any kind of test here. So this will be the cross validation in the time series split, right? So this is one good visualization to understand time series split inside our chronological train test split of the training set only and not the test set. Okay, so end of this. Okay, let's see. Before that, before moving on to standardization things and all, we will see how a feature DF looks like. So we have to move to the standardization step in the next video. So this is how our data is. We'll see featured df.info. Okay, we have 19 columns, non-null columns, 1 date time, and weather will be we have changed the number to code, right? Sorry, code to value with that YAML file. So this will be float, and day, month, weekday will be the integers, and all the other things will be float. Okay, so with this we will start the data standardization in the next video, so that our features have different magnitudes like rainfall, that will be in millimeter or centimeter, the temperature in degrees or Celsius, and the wind speed like 1 to 10 and all. See, temp max will be one scale, rainfall will be in another scale, so wind speed will be in another scale. So if not scale, these features with large ranges can dominate the model, right? So with the scaling, with the scaling, we can like, it is a basic understanding that with scaling, all the features contribute fairly, right? So so weather is kind of normal kind of distribution, right? So that we didn't use min max scalar or robust scalar. What we will going instead of min max scalar and robust scalar, we will be using standard scalar. Okay, so this is a normal kind of distribution, so I have taken a standard scalar. And when we have data with extreme values, we can go for robust scalar, and if any data is bounded between 0 to 1, we can go with min max scalar. But since our data is kind of normal, we are going to stick with the standard scalar. So let's see that in the next video.